Hello everyone. So today I'm going to show you how to adjust this foot placement using Unreal Engine 5 control rig. So as you can see here, you can see the foot is properly placed on the ground and it works in any type of a surface, as you can see here. If I go to the staircase, you can see foot is placed properly, and if I go in here, also foot adjusts nicely to the surface. Alright, so let's see how to do this today. And this episode is sponsored by these generous patrons. Thank you very much for the support. Right, so this is what we have at the moment. As you can see, the foot location adjusts properly, but the rotation of the foot is not still matching, as you can see here. So the rotation part is the main thing that we are going to look into today. Right, so okay, first let me open the control rig that I am using here. So we worked on this control rig up to this point in the previous episode, so I'm going to pick up from that point. Okay, so first of all, we have this trace foot function, which I have defined like this, and here what we do is we determine the location by doing a line trace. We determine the location that this controller needs to have in order to properly place the foot on the ground. So here I can also adjust the rotation as well. So if I adjust the rotation of this foot, you can see the rotation of the, if I adjust the rotation of this 𝐂𝐴 controller, the rotation of the foot also adjusted, as you can see here, and that's common for both foot, left and right. Okay, so now let's see how to use this to adjust the rotation of the foot to properly place it on the ground. So for that, first we do have this hit normal, and so we can use this hit normal to derive the rotation this controller needs to have. So for that, there is a node called a math in the control rig. So here we are going to use we are going to change the rotation of the controller that we get as a parameter with a name like this. So as an input, I'll use get control transform. No, not that. Yeah, this is the root. So as the control, I'll plug this control parameter. Right, so I'll use local space, and here what we need to set is the rotation of the control. So here we have set translation. So since we actually need to set both translation and rotation, instead of using this set translation, I'll use set transform using the type control, and I'll use the control name given here. right. Then so actually it's not the initial transform we are setting here, so we can leave this one unticked. And let me expand this. So I'll remove this this node, because we can set it here using a single node. So let me connect it like this, and here we get the hit location. So this is what we need if there is a hit. Also there in order to have a smooth transformation, we can do a accumulate loop as well. It's like this, accumulate loop transform. Great. Now here the target value will be coming from, we have to expand this because the location is coming from here, the translation, and the rotation will be coming from here after I complete this calculation. And the initial value will be whatever the value we have here, but we are using global space. Would that be a problem? Okay, just in case, let me make another node here and connect the control. Let's use global space and connect the transform here as the initial value, and the blend I'll set to 1 for now. We can adjust this value later on if it is too slow, if it feels like too slow or too fast. Right. Oh wait, this should be the scale. We don't need to change the scale at all, so I'll connect the initial value. Right. Now as you can see here, rotation is not properly set, so that's why it kind of go haywire. Right. Actually rotation by default I think we get 0 0 0. So now let's complete this calculation. So how do we calculate? So for this actually, as I said, the target is aligning with this hit normal. This is the target, and which axis we need to align, so that depends on which axis we need to align for this particular bone. And here we are talking about the IK ball L and IK ball R. So if I go to this 𝐂𝐚𝐭𝐫𝐴 ball R, so I have used the same location and rotation for the controller ball controllers as same as this ball bones. So here you can see y-axis is up for the right foot, and here y-axis is down for the left foot. So if I make this one 0 and y1, wait, let me expand this and connect the rotation like this. Compile, not working yet. One more thing, this kind should be a direction, not a rotation, not a location, because this using this hit normal we are giving a direction. Now as you can see here, the left foot is now facing up, but the right foot is facing down. That's because for the right foot, for the other foot, is it right or left? It is left, right. For this one, left foot, y is down, so that means here the axis y value should be -1. Now you see this one turns to the correct side, but since we are using trace foot function, we can promote this as a parameter. Let's just call it axis and compile. Now if I go to the graph here, for the right leg we can now put +1. So right, both foot now facing upwards, but they are still kind of looking at each other in an odd way. So yeah, we can fix this. We don't need to override this one. We can fix that by adding a secondary axis and a target. So in order to define a target, so we can use another target to tell which direction this foot should be facing. So let me select this PV. PV stands for pole vector, and the secondary axis is also referred to as pole vector. So let me duplicate this PVL and PVR, and I'll call it PVL foot, this one PVR foot, because we are using this for foots. These pole vectors we used it to mainly define the direction knee is looking at. Right, now let me move down this foot pole vectors like this, and I'll set initial transform from current. Okay, so now let's test. Let's test with the left foot. Let me get a reference to the left for PVL foot. I only need the translation. Oh wait, not set, get. Translation. So this is going to be a location. The kind is location because we are giving the target as a location. So I'll connect the target like this. Now you can see this left foot, actually I think both foot rotated in some way. So if I again go to the mannequin here, red vector, the X direction should be facing forward. So to make that happen, now here let's change the secondary axis. If I remove 0 and x1, nothing happens. y1, no, that's wrong. z1 -1. Right, here the foot looks at this one properly if I set x to 1 and z to -1. So which kind of matches, or I'm not sure. Right, so anyway, that works. So if I move this, you can see the foot is also turning to that the location that we give by this one. Right, so let me promote this one also as a parameter, because we need another controller for the different controllers for left foot and right foot. So I'll name this one PV foot, and also we need different axis as well. So let me promote this as a variable. Secondary axis. Right, now if I go to the regraph, right, this is correct. For the left foot we should give, for the right foot we should give PVR foot. Left foot is okay. Right, now we need to adjust the secondary axis. For that, -1 and 0 0 works. If I compile and if I move, you see right foot is adjusting to the location of this PVR foot controller. Right, here for the left foot it seems like secondary axis is wrong. Right, so I connected this hit condition 1 for true, 0 for false again here for the blend value, so we will not get any invalid rotations. And also I think I was wrong about what I thought about the kind, because when I have 1, you see when I give the location, this I'm not sure how this foot behaves, even though the right foot is okay, the left foot behaves in a kind of odd way. So but if I change it to the direction, both foot works fine. See, right, so let's test now. So it seems fine here. If I go here also, yeah, rotation is working properly. How about this? Right, yeah, foot is adjusting nicely to the surface. Okay, what else we need to fix? So when we are in the plane surface, you can see the character is kind of slanted towards forward, and also there is a gap between the back foot. That's because we adjust the location, but when we again rotate, the foot moves up, so that's the reason for that. So what can we do about it? Other than that, I think everything is fine. Okay, let's do something about that too. Here I think, even though in the pelvis adjustment I have assumed that the pelvis always sits in between in the exact middle of the both ball L and ball R in horizontal space, in horizontal plane. So that's why I used 0.5, but when I check it here, if I use the right, if I select where's ball R, here is the ball R here, and ball L is here, but pelvis is in the middle. It's okay in this direction. If I look into the other direction, you see pelvis is here and the ball L is here, ball R is here. So that means the pelvis is more closer to the right leg, right foot. So therefore, instead of making this on 0.5, I'll make it 0.4. And let's see. Okay. Also, why don't we speed up the adjustment a little bit? We can do that here. Blend. If it is true, let's make it 2 or whatever, 3 instead of 1. Right. Also, compared to this A pose, I think in the idle animation the pelvis is a little bit moved down. So to come, because the leg is a little bit bent here, the knee in the knee compared to here. So to compensate for that, also in this adjust pelvis section, this is where we set the pelvis. So here let's add another vector and make this some, I don't know, move down like 4 units. Maybe that's too much. 3 units. Okay. Right, now let's check. Okay, but that problem, we still have that problem. Oh, actually here making it 1 makes it closer to A. Making it 0 makes it closer to left. So I'll use something like 0.6. Still, I'm not sure if this would be perfect. No, yet. But yeah, this is good enough for now. So I'm gonna stop this episode right here, and yeah, it's great actually. Okay, and later on, if I find a better way than this, I will definitely share. But for now, I'm gonna stop it right here. Great. Okay, it is working. All right. So and thanks for watching. So as always, project files will be available for the download through Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. So thanks for watching. See you in another episode. Goodbye.